this activity, you are going to write the functions as inverses of each other. You'll use Desmos to graph each function, and then you're going to identify key features and transformations. Don't forget, the exponential and the logarithmic forms are inverses of each other. So when you look at these first two, we have these in our notes. And in fact, I believe we graphed the exponential, and I think we also graphed the logarithmic by hand. And these were all of the key features that we pulled in our notes that we discussed. I want you to compare. So left side, right side, these should be inverses of each other. Here I've given you an exponential. You are going to write the inverse of this exponential. Don't forget, you might have to look back in your notes. We've done this a few times. To write the inverse, you are going to switch your x and your y. You're going to move things around so that you have, in this instance, your base, you'd have 2 raised to the y. You need that alone on one side of the equal sign. And after that base raised to the exponent is alone, you can go ahead and move it into logarithmic form. So you will be comparing these two. Then I also want you to think about transformations from your exponential. From here would be your parent function. So what happens when we go from here, your parent function, into my function y equals 2 raised to the x plus 3, to whatever you're going to fill in here, the inverse of log base 2 of x plus 3. And you'll also kind of compare at the end what you're noticing between the inverse relationships between these two functions. On your second page, I've given you, this is the natural base and your natural log. Don't forget, when you're doing these inverses, you've got a base of e that's implied. Remember, the inverse of e is the natural log. And then when you're done with this, you're going to compare and contrast exponential functions and logarithmic functions. I want more than just a sentence or two. Really expound on this. Use your English skills from what you learn in English comp. Break me down some paragraphs. The more in depth you go into this, the more observations you make, I will more than likely award you even more extra credit points. If you just kind of do the bare minimum, I might give you some credit. I want to see if these are correct or somewhat on track. I will kind of be grading this based on accuracy. And then I want you to answer these two questions. Now, these questions may not, number 3 and number 4, may not directly be within this activity, but I want you to extend your thinking and determine, could those two things happen, and what would make them, what would have to occur to make them happen. So I'm going to go ahead, we're going to go, let me pull up Desmos. I did in class, we looked at these two and we looked at these two. So let me grab Desmos and we will take a look at some of these together. First of all, my first line, let me do that exponential. We have 2 raised to the x. Okay, and now notice here we have that asymptote is the x-axis, so that's y equals 0. Also notice you have a y-intercept at 0, 1. And again, you can refer back to the notes and what I have printed for you and try to kind of, look at what's in your notes and see it in the graph. If I punch in, let's do the inverse. So the inverse of y equals 2 to the x is y equals log base 2 of x. So what you're going to do to put a logarithm in, you're going to go down to the keypad. You'll go to functions, go to miscellaneous, and second column, second from the bottom, is log base a. So I'm going to type in my base is 2 and inside my parenthesis x. So these are inverses. Now let's make some observations. So we already said asymptote is at y equals 0. Well, look at your inverse, the logarithm. Now you have an asymptote. You see how this graph is coming? It's hugging the y-axis. Well, now your asymptote is at x equals 0. So we went from y equals 0 to x equals 0. Also notice here, we had a y-intercept at 0, 1. We had no x-intercept. Back on that. And when you look at the inverse, the logarithm, well, now you don't have a y-intercept because, of course, that graph is never touching the y-axis. But we do have an x-intercept. So take a look at that relationship. Also notice, look at their shapes. You see how they're both curved, but their end behavior is different. Here, as x approaches negative infinity, my y values are approaching 0. And now here, I can't say as x approaches negative infinity because my x values will never, ever, ever be less than 0. So now I have to say as x approaches 0, my y values are going down. They're going to negative infinity. So take a look and compare these a little bit. Now also notice, if you remember from geometry, reflections across the line y equals x. So there's my line y equals x. Now if you could imagine picking this graph up, folding it on that green line, that y equals x. Well, your exponential and your logarithmic graphs would be right on top of each other. They're symmetric about the line y equals x. They are reflections across that line. When you are calculating your inverse functions, so when you go here or you go here, when you punch these two into Desmos, you should be able to put in that line y equals x, and you should see that reflection, that symmetry about those two graphs. If you don't, you've probably maybe done something wrong when you created the inverse. If you need help, please contact me. I'm more than happy to help you. So now let's move on. I'm going to take that out. Let's take a look at this guy. We have y equals 2 to the x plus 3. Let's compare it to the parent function. I'm going to type in 2 raised to the x plus 3. Now, just as an FYI, in this activity, I've had a few students ask me about this. If you are going to put something needs to be in the exponent position in Desmos, you would need to use parentheses around your exponent. Otherwise, it will drop it down. It will give it a k value. So this plus 3, that's our k, and we already know from our study of transformations, that's a vertical shift up 3. So here's my transform graph. My red is the parent function, and notice the difference. My asymptote has changed. See how this line was skating along y equals 0? Well, it's moved up 3. We had a vertical shift up 3, so that entire asymptote moved up 3. So now my asymptote is at y equals 3. Also take notice here, we had a y-intercept of 0, 1. And when we did that vertical shift, we're now at 0, 4. Well, we did a shift of 3 up. Look at your y values. 1 plus 3 is 4. Your end behavior now, as x approaches negative infinity, so in my parent function, y was approaching 0. Well, now it is approaching 3. So as x approaches negative infinity, y is approaching 3. Still notice on the other side, if I am approaching positive infinity, both of these graphs, the end behavior is the same. My only difference was in as x approaches negative infinity. Also notice, what do we do? We still don't have an x-intercept. My range now, the range of my parent function, y values were all greater than 0. Well, now my range is y is greater than 3. Notice there's no y values on this purple graph that are below 3. Now let's take a look at this guy. I'm going to move that one out. And we're going to go into looking at the inverse. Now this inverse, I'm not going to do it on the video, but again, switch your x and your y. So you would have x equals 2 raised to the y plus 3. You would need to subtract that 3, move it to the other side before you convert this into logarithmic form. And when you do that, you are going to get, let me go down, shortcut, or my keyboard, functions, miscellaneous, log. We are going to have log base 2. That is going to be x minus 3. Oh, I'm outside of my parentheses. Oh, no, 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 no. There we go. Okay, so let's even just look at these functions. Notice here, we had a vertical shift up. And be careful, because I've had a few students say, well, inverses are opposites. Well, if it's opposite, if you think your inverse would have if it's a vertical shift up, you would think the opposite would be a vertical shift down. Remember, these are inverses. So if you notice, when we take that inverse, it doesn't shift it down, it shifts the graph to the right. Keep that in mind as you're doing these. So here we go, let's take a look. Check it out, we have the same shape. If I put in the line y equals x, notice my purple and my black graph, the exponential is here in the purple, the logarithmic is in the black. They are symmetric about the line y equals x. Let's take a look at a few other key features of my inverse. We've already talked about this guy, so let's talk about this guy. We had an asymptote at y equals 3. Well, now check it out. My asymptote is at x equals 3. My domain, so think about the domain of any exponential, it's going to be all real numbers. But now check out the domain of the logarithm. Here, I had all real numbers on the exponential. Well, now I have a restriction. X has to be greater than 3. I have no x values to the left of x equals 3. If I look at range, so my range here, we talked about that a little bit. Range has to be greater than 3. Well, now in the logarithm, my range is all real numbers. I've got y values going all the way down to negative infinity, and they will continue to increase to positive infinity. I can move this graph forever. We also had intercepts. So on my exponential, I had a y-intercept of 0, 4. I had no x-intercept. Well, now check out the logarithm, the inverse of that exponential. Now I have an x-intercept, I lost my coordinate. I have an x-intercept at 4, 0, but I have no y-intercept. And then end behavior. So as x approaches, I can't say negative infinity because my x values, my domain, is x is greater than 3. I have that asymptote at x equals 3. So that means when I write my end behavior, I would write as x approaches 3, because it's never going to go past 3, where are my y values going? Well, they're going down forever, so it's approaching negative infinity. As x approaches positive infinity, and notice the x values do get bigger and bigger and bigger. I can go x equals 30. I'm going to come up with a y value. My graph is still there. So as x is approaching positive infinity, notice how the y values are going up. They are increasing, so they are going to positive infinity. And again, notice too, we did a transformation. This was 3 units to the right. So on my original parent function of this guy, which let's just go ahead and pop him in. log base 2 of x. So here's my parent function, and again, your parent functions start out at an x-intercept of 1, 0. Well, if I move this guy 3 units to the right, my h value is a positive 3. 1 plus 3 is 4. And then take a look too at the differences between the end behavior here between your parent function and your transformed graph. Here I had to say as x approaches 0, y goes to negative infinity. Here I had to go as x approaches 3, y goes to negative infinity. And again, it's going to be the same as the graph goes off to positive infinity. My y values, my x goes to positive infinity, my y values are also going to positive infinity. So I'm going to leave you guys to do this on your own. Work with a partner if you can have one. I know we're in this weird online setting and with the distance, but if you have another friend in your class or even in one of the other Algebra 2 classes, you know, work together. I'm really happy if you guys would do that. Make some observations. I would like you to extend your thinking on this activity a bit. And, you know, maybe try some other transformations, ones that I didn't give you here. What happens if you move the graph up and left or right, or up, down, left, right? How does that change things? What if you put a negative out front, you know, making your a value negative? Take a look at those reflections and compare them to the parent function and maybe do the same on your inverses. Just play around, and again, I am more than willing, if I get a really stellar observation, I'm willing to put an extra 20 extra credit points in the grade book for that, which would pretty much be like a free homework pass. If it's really good too, if I get something super outstanding, you know, I might allow that student to apply some extra points to a test. So please, you know, use this opportunity. I do have to close this assignment down on Friday, so make sure that you get this done. If you have any questions, if you get stuck, you're not certain, please contact me.